In this video we are going to see how vaccines work and what are the different kinds of vaccines. Stay till the end to go through all necessary information. Kindly subscribe to this channel for more such videos. Vaccines produce their protective effect by inducing active immunity and providing immunological memory. Immunological memory enables the immune system to recognize and respond rapidly to exposure to natural infection at a later date and thus to prevent or modify the disease. Antibodies can be detected in blood or serum, but, even in the absence of detectable antibodies, immunological memory may still be present. Cell-mediated responses to some vaccines, e.g. BCG, see Chapter 32, may be detectable by skin testing but do not necessarily indicate protection. Vaccines can be made from inactivated, killed, or attenuated live organisms, secreted products, recombinant components or the constituents of cell walls. Vaccines such as pertussis and inactivated poliomyelitis virus (IPV) contain inactivated bacteria or viruses. Other vaccines contain only the antigens that are important for protection. For example, tetanus and diphtheria vaccines contain inactivated toxins, tocoids. Influenza vaccine contains a surface protein called hemagglutinin, and pneumococcal vaccine contains the polysaccharide from the capsule. Live attenuated vaccines include yellow fever, measles, mumps and rubella (MMR), and BCG. From birth and in early infancy and childhood, humans are exposed to countless numbers of foreign antigens and infectious agents in the everyday environment. Responding to these stimuli helps the immune system to develop and mature. Compared with exposure in the natural environment, vaccines provide specific stimulation to a small number of antigens. Responding to these specific antigens uses only a tiny proportion of the capacity of an infant's immune system. Offit al. 2002. If an infant's immune system could be exhausted by multiple vaccines, one would expect vaccinated children to be at a higher risk of serious infections. Studies to investigate whether vaccines increase susceptibility to serious infections have shown no evidence of such an effect, with infection rates generally being lower in vaccinated children. Hvid al. 2005, Miller al. 2003. Inactivated vaccines. A first injection of an inactivated vaccine or toxoid in an individual without prior exposure to the antigen produces a primary antibody response. This response is dominated by IgM antibody initially, followed by IgG antibody. 2 or more injections may be needed to elicit such a response in young infants. This is usually called the primary course. Depending on the potency of the product and the time interval, further injections will lead to an accelerated response dominated by IgG, the secondary response. Following a primary course of vaccination, antibodies may persist for months or years. Even if the level of detectable antibody subsequently falls, the immune system has been primed and an individual may be protected. Further reinforcing doses of vaccine are used to boost immunity and to provide longer-term protection. Inactivated vaccines cannot cause the disease that they are designed to prevent. Plain polysaccharide antigens do not stimulate the immune system as broadly as protein antigens such as tetanus, diphtheria or influenza. Therefore, protection from such vaccines is not long-lasting and response in infants and young children is poor. Some polysaccharide vaccines have been enhanced by conjugation, where the polysaccharide antigen is attached to a protein carrier, e.g. Hib and Men-C vaccines. This enables the immune system to respond more broadly to the antigen to provide immunological memory, even in young children. Some inactivated vaccines contain adjuvants, substances that enhance the antibody response. Most combination vaccines contain adjuvants such as aluminium phosphate or aluminium hydroxide. Live vaccines. Live attenuated virus vaccines, such as MMR, usually promote a full, long-lasting antibody response after 1 or 2 doses. To produce an immune response, the live organism must replicate, grow, in the vaccinated individual over a period of time, days or weeks. The immune system responds in the same way as it does to natural infection. It usually does this without causing the disease itself because the vaccine virus is weakened or attenuated, but, for some vaccines, a mild form of the disease may rarely occur, e.g. a rash following measles containing vaccines. Vaccine failure. No vaccine offers 100% protection and a small proportion of individuals get infected despite vaccination. Vaccines can fail in 2 main ways, known as primary or secondary vaccine failures. Primary failure occurs when an individual fails to make an initial immunological response to the vaccine. Infection can therefore occur at any point after vaccination. A good example of primary vaccine failure is the 5 to 10% of children who do not respond to the measles component of the first dose of MMR. The risk of measles in such children is reduced by offering an additional dose of vaccine, usually before school entry. Secondary failure occurs when an individual responds initially but then protection wanes over time. The incidence of secondary vaccine failure therefore increases with time. Individuals who acquire infection despite vaccination may have a modified, milder form of disease and are less likely to suffer serious complications than those who have never been vaccinated. An example of secondary vaccine failure is Pertussis Vaccine, when protection against whooping cough after 3 doses is initially high but declines as a child gets older. A 4th booster dose is given to improve protection during the school years.